everyone, welcome back to Cosmo's Universe. My name is Matt and today I'm going to be telling you all about binary code. If you like maths, you'll love this. And if you don't like maths, you might still like this, but you probably won't. Roll the intro. So binary code, you could say it's a language. I would say it's a counting system. It's a computer-based language made entirely of ones and zeros. It's used for a lot of things such as programming and is there in most digital systems such as CDs, DVDs, the devices that run those, light systems, more complex things like, you know, the camera I'm using right now, probably binary code is used to make it work. I'll get into it. I'm going to show you how you can count binary code using nothing but your hands to start off. So, let's say if I have my fingers, if it is up, it represents true, on, 1, whatever you want to call it. If it is down, it is false, 0, off. Binary works by stringing 8 ones and zeros together, each with a value of a number. So, if I take these fingers for example, that would be 1, 2, 4, 8, 16, 32, 64, and then 128. This way, any number up to 255 can be calculated. If you pause the video before and try to work that out for yourself, then well done, you're a mathematician. See, binary is a base 2 system. The system we use to count is base 10. So we have 10 digits, and once we go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, we loop over with the same digits, so it's it's 11. I don't know why it's not called 1-1. But we have the 1 again, instead of creating a new digit. For example, they will be spelled differently. 1 would equal 1, 2 would equal 10, 3 would equal 11, 4 would equal 101, and so on and so forth. Hence the old joke, there are only 10 kinds of people in the world. Those who understand binary and those who don't. Hey? Huh? Yeah? No? Never mind. Binary has also been used for ciphers in this way, and that's one of the biggest uses we're exploring in this video. Binary has also been used for ciphers in this way. You could string together the digits to create the numbers 1 to 26 in binary and then assign them to the corresponding letter to that, and then string them together to spell it out. So if you translated it into the letters, it would mean a message, and use that as a code. It would be pretty tedious to work out though. It will be easy enough, but it would take a long time. If you added a Caesar shift to that, however, oh boy, that would be a difficult one. Well, not so much difficult as tedious, but like I said before, it just takes time. The last use I'll mention is to do with SETI, and they're an organisation called the Search for Extraterrestrial Intelligence, and essentially they use radio waves to transmit images into space to look for life, but also receive radio waves that they encounter, and usually they're just random radiation in space rather than actual intelligent life. Otherwise, you know, we would know what we found by now. To my understanding, they essentially use the frequencies, I think in hertz or something, and correspond that to numbers in binary code. But it's quite complicated. It's relevant, but it's not what I'm going to explain in this video. So don't worry about that. You can go and search it up for yourself if you have time. What I'm going to do now is focus on creating and decoding images, so to speak. So I'm going to put something up on screen now, maybe a thing from the old video. Imagine you have an area of squares. Each square represents a pixel. And to make this simpler, we're going to start with a smaller space. And you could say each square is either black or white, true or false, on or off. See where I'm going with this? You could say that 0 equals white and 1 equals black. So then you could create a string of binary numbers, not necessarily an 8. This isn't to create words or anything. This is just 1 per square, 1 per pixel, to fill in each pixel accordingly, black or white, and then you could literally draw something from that. The difficulties that arise in creating this image are that sometimes you won't fill it incorrectly. How do you know when to stop and go on to the next row or column, depending on how you're doing it? The way to fix this is to have each length and width value be a prime number. So you've got a prime number of pixels by another prime number of pixels, and then always place the X before the Y. That way you'll never have a problem of knowing when to stop. In fact, if you made it clear what the X and Y values were for the image, they wouldn't even need to be prime numbers. unless you're always sending images that are the same ratio. It's all up to you. A simple coded messaging system could also work three-dimensionally, which is something I actually thought of when making this rather than something I researched. But again, I'm not going to go into that because I don't have much time. But imagine doing this three-dimensionally with depth as well. You would simply need a third value to go over with, as long as it went X, Y, Z, and you could create a three-dimensional image, which would be a whole other level. Lastly, I'm going to add one more idea about how to create images with binary. How would you get colour? It's all very well to be able to draw things, but in black and white. What about colour? How to make a, we have colour pictures and videos since like the 1940s or 50s. How's this done? Think about this. Well, 0 equals white. 1 equals black. So 2 equals red. 3 equals blue. 4 equals green. And there, I'll put the test image up again. You can just see, you can add more numbers to create more colours. And this isn't necessarily binary code. This isn't really programming technology binary code used as a language. But this is more as a device for creating images. But again, there are many different forms of binary code. Like I've just sort of given a little overview here. So what we've learned today is what binary code is, how it can be used, specifically concerning images in both 2D, 3D, and with colour. Before I finish, here's a bibliography of all the websites. But I didn't actually really go and research and use information from websites. I made an old video about this in the Thought Films, as you may know. And I learned most of this in a maths class in 2013. So these are more websites that I went to afterwards, which go across the same kind of things, and you might want to have a look at if you're looking for more information. But generally speaking, I didn't do a massive amount of research for this. And that's it. So if you did enjoy, please remember to give the video a like and share it with your friends and family so we get more people to watch my content and enjoy. All criticisms in the comments are greatly appreciated so that I can make my videos better. And remember, don't forget to subscribe. Remember, don't forget. Well done, Matthew. Don't forget to subscribe to be notified of all the new content coming on this channel. Most of it is gaming, especially Minecraft, as well as a few other indie games we've got around. Occasionally I'll do an animation, but we've got more of Math-Matters and the piano recital videos coming up all the time. I know, Jumble, I will get around to the animations, but maybe I need to make another vlog about that as well. So, until the next time, bye bye.